For levels 1 and 2, we need to be able to solve something that's already in factored form, and we need to be able to factor using a GCF and solve. Now, factoring allows us to be able to solve equations so that we can get the value of our variable. What does x equal? In order to factor, our equations have to be set equal to 0. Now, both example 1a and 1b are factored form of an equation. And when they're in factored form, we can set each factor equal to 0 and solve. So I have 2g plus 6, that equals 0, and 3g minus 15 equals 0. Then we have just a two-step equation that we need to solve to find out what does g equal. So to do that, we'll subtract 6 from both sides, leaving us with 2g is equal to negative 6. And then divide by 2 on both sides, giving us that g equals negative 3. What that g will do is when it's plugged in to this factor, that will equal 0. And anything times 0 equals 0. That's why we're able to set each factor equal to 0, and why our factors have to be set equal to 0 in order to solve. For this other factor, we'll add 15 to both sides, giving us 3g equals 15. Then divide by 3 on both sides so that g is equal to 5. So my answers, and there are two of them, is g equals negative 3 and g equals 5. And you must list both. Example 1b, we're going to set each one equal to 0. So 4h plus 2 equals 0, and 3h minus 9 equals 0. We'll subtract 2 from both sides. So 4h will equal negative 2. Then we need to divide by 4 on both sides. H is equal to, reduce that fraction and we get negative 1/2. For our second factor, we'll add 9 to both sides. 3h is equal to 9. Divide by 3 on both sides so that h is equal to 3. So our solutions are h equals negative 1/2 and h equals 3. That's level 1 problems. Level 2 problems, we have to actually do a little bit of factoring. The first step in factoring, no matter which kind you're using, is to take a GCF out. In this case, our GCF is 8b. Now we're not dividing it on both sides, so it doesn't just disappear. We are factoring it out. So 8b must go in the front, and b minus 5 is left inside the parentheses. Now it's in factored form, just like our problems above. 8b equals 0. b minus 5 equals 0. So we'll divide by 8 on both sides, giving us that b equals 0. And here we'll add 5 to both sides, giving us that b equals 5. Example 2b. Look for a GCF first. In this case, GCF is 3c. So 3c will go in front and leave us with c plus 2. So we have factored form. So we'll set each factor equal to 0 and solve. Divide by 3 on both sides, giving us c is equal to 0. And finally, we'll need to subtract 2 on both sides, so c is equal to negative 2. Our solutions are c equals 0 and c equals negative 2. For our last two examples, they look a little bit different because so far we have been given examples where the equation already equals 0. Now we have to actually make it equal 0, then factor, and solve. We always want the highest exponent, that term, to be positive. So instead of subtracting x squared from both sides, we're going to subtract 3x from both sides. So x squared minus 3x equals 0. And then factor. I can take an x out of both, giving us x minus 3 equals 0. And that's factored form. So x equals 0 and x minus 3 equals 0. With this one needs a little more solving, so we'll add 3 to both sides and give us x is equal to 3. Now the reason why we knew that these were factored form is because when there's only two terms, both terms would have to be perfect squares with a minus in the middle. And if there's no exponent for the x, it can't be a perfect square. So each of these, when I factored, I knew I was done factoring because there was no other method that would work to go further. Good rule of thumb would be if you got rid of all the exponents, you're factored completely. Last example. We'll need to add 10y to both sides so that we can keep the 5y squared positive. We have 5y squared plus 10y equals 0. Then we'll divide by 5y on both sides. So y plus 2 is what's remaining. And we'll set each factor equal to 0. 5y equals 0. Y plus 2 equals 0. And then solve. Divide by 5, giving us that y equals 0. And subtract 2, leaving us with y equals negative 2.